question, maybe not event storming, but things like event sourcing as a design and so on. May I ask, who is technical as in developers? Just a show of hands for, okay. Okay, so, and who is on the sort of business and project management and so forth side? Okay, good, okay, the mixed group. So the technical folks among you may have heard of event sourcing and command query response separation, these things before. This talk is kind of not really for you, it's actually aimed at the business folks. It is a talk for you as well, right? But it's aimed at the business folks from the point of view of an approach which really has a business reason for using it, because it makes building systems potentially simpler. So let's have a bit of an overview. I'm not going to, this is the worst slide of them all, it's got the most bullets. Can you even see that from the back? Okay, good. In a nutshell, the whole idea around event-based systems is that you are the sum of everything that happened to you before. You as a person are arguably the product of everything that happened since childhood, and all these things that happen to you all have one thing in common. They happen at a particular moment in time. By our perception, time happens in a sort of linear fashion. It's a very Newtonian, non-Einsteinian kind of way of looking at the world, but a nice simplification. And so your current state, frame of mind, and who you are is a lot dependent on what happened before. Now, what event sourcing is based on as an idea is that this is also very true for systems, namely the kind of business systems where we do a web app or have some sort of a database and so on. The database is more or less is a snapshot of how things are at the moment. But what's really interesting is how it got there. One extreme look at view of the world is that you don't actually need a traditional database, you just have a log of all the events which happened before, and from that you can build the current state of something. We'll look at a number of examples, and we'll soon, however, come to what the purpose of it all is. In a nutshell, you get a timeline of events that can be used to identify building blocks of a system. These are the business sort of building blocks which need to fit together, not necessarily technical artifacts, they're not that interesting. And now here comes the project management take on this. There's a bit of a technique involved in assigning those building blocks or services, or what do you call it, to dev teams to deliver this stuff. Because depending on how you do it, your projects either get a lot simpler to manage or harder to manage. That's because the building blocks, if they map on the business domain well, determine how much communication has to happen between teams and team members. And the more communication between, especially geographically separate teams and team members needs to happen, the more delays you get, the more disconnects you get, the slower things get. So ultimately, the outcome of this technique is supposed to be a breakdown into technical deliverables where everything is single purpose, very small, and therefore easy to build, and yet the orchestra plays in tune. Now that's heavy snake oil, everybody has been selling that forever, which is why we have a section at the end of why it doesn't work, or sometimes doesn't work, okay? So gonna make this the second half hopefully a little interactive, and lots of Q&A, but let's get everything here. So we have an example system. Which really, so this is probably a little small. Our system is called FeedStorm. Our founder has put that, our hypothetical founder has put that on a napkin at a coffee shop, and it's the new office. It scans news as they happen. Give us a news feed, tell us what you're interested in, and we'll send you an email alert when it happens. So this is brand new, no one has ever done this before, right? So you get yourself basically a search, where you put some keywords in, and then all the news feeds, RSS feeds, atom feeds, and so on you want to scan on a regular basis. If anything appears in these things which is of interest, it notifies you. Certain to be the new Silicon Valley, whatever it is. And here is a mock-up which he made on a napkin as a specification for the dev teams. Our job is to break that down into deliverables and do an architecture and do it in such a way that at the end, the whole thing is easy to deliver, maintainable, scalable, all the rest of it, right? So let's do it. First, let's do a bit of a walkthrough here. Feed storm, step one. Can you still read that from the back? Sketchy. Let's see, make it a bit bigger. That any better? Okay. So feed storm scans news as they happen. Our founders and financing, we're building it. Here's how it works. Step one, register on feed storm. Step two, give us a news feed URI and search expression, very geeky founder. There is no step three, just sit back and watch the notifications roll into your inbox. Very simple system, bound to work out as a business idea. So let's register. And you just give it an email and a password, very quick registration. And after you register, you can enter a search, use a search term, just some whatever, keywords or something. And you can add those searches and delete them and so on. For example, if you have something, if you have your Pluto Horizon Pro search, and you add a feed to that, you can, that's actually a Manchester United feed. You can add various URIs of RSS and Atom feeds to it, and then because you registered with your email, it sends you an email each time something new happens. You're not impressed? It's supposed to be good. It's kind of supposed to be some bite-sized small things like demo kind of thing. Okay, never mind. It's okay. So here is the so this is feeds. This is it. This is feed storm. An idea was the time of which has come, and so on. And let's go through this, right? If we do this technique called event storming, which somebody, Alberto Brandolini, has invented, or at least popularized, and it looks like this. Right? That's a wall full of stickies, right? It's a wall full of sticky notes. I even brought some, but you're too far away. In a nutshell, imagine you put groups of folks together and you figure out what happens in sequence. For example, somebody registers, we saw that somebody registers with email and so forth. And if you do that in here, and this guy hits register, an event has occurred. User registered, right? Okay, so user registered, and this is a trivial example. You'll still be amazed how many events you get once we look at them in total, but basically you get groups of people who brainstorm what happens in order in a system like that. User registered is a first event. After you register, what do? You probably want to log in. So let's say you go back here, and now they're registered, we can sign in. User authenticated could be the next event down the line. Then after you logged in, you could go and add a new search. Search created or search added might be another event. After that, you add a feed. Use feed added, right? So all these happen at a particular moment in time. And that's significant. We come to why that matters. May I ask of the developers who has worked with event sourcing before? Yeah. Yeah. It matters because we can restate, we can restore the state of something. So, but here it's mainly at this point a communications tool. We have a wall full of sticky notes, a timeline, if you will, with all the events on the wall. I hope that we can do a more practical example a little later if there's time. And these occur in sequence. Here is what we have. Let me show you what the end result of this looks like. Extremely geeky, but is there a way of turning those lights off so we can so we can see that a little better? That's better. Okay. All right, so now we're better. So you can see a sequence of events which describe the entire life cycle of somebody signing up with a little system. It goes from user registered to login succeeded. There's various failure conditions as well, which we will be looking at. You can see each of those carry data with them, email, password, and so forth. Search added. Feed added. Feed added to search. Feed item received. Search term matched. If a search term has been matched by this backend service, which handles all that stuff. Login failed. Feed removed from search. Feed deleted. Search deleted. User unregistered. Password reset. So the entire life cycle from, yes, I want to register with this thing. Yeah, let's have a search. I get some, look, something was matched. I was notified of that. To, yeah, it's a really boring service. I want to unregister. I want to get out of here. You can see that you can describe an entire system in those terms, from beginning to end. Any questions so far? So this is the basic technique. Brainstorming, a bunch of sticky notes on the wall, resulting in events. We'll see in a moment how these are used to break the system down into components and all the rest of it. Robert.
So Robert, presumably like all the subject matter experts are kind of on the discussion and so on, but is there any kind of a, before you actually start building an MVP or something, is there like some kind of validation process or like a pre-QA kind of thing you can do to kind of make sure that you kind of got everything, or
yeah, why would you do that? No, obviously, you said it already, right? What you need, this is an activity which, if you do that just technicians in a room, then it looks like this, but it's not very useful, right? This is very much something which requires business stakeholders in the room. Technical, this is a communications tool, right? That's why it's best done with a huge roll of paper on the wall and a bunch of sticky notes. It's quite a revealing exercise. What comes out of the woodwork when you actually do this, and the validation happens hopefully on the spot. But we'll circle back to that later to see how, if you miss the spot, how you can find that. But the idea is to front load as much as possible of that. And it's a rather efficient way of gathering requirements. All right, so here's a bunch of those events. And let's see. So, with that in hand, this is a very technical piece which is supposed to describe an event source system based on something called command query response separation. Right? The idea is the idea of having the events is to next find the pieces or the aggregates which handle commands. Unlike a traditional system, this is going to have commands such as register and asynchronously later events will happen. This is too complicated. It's from Microsoft's documentation on event sourcing. So let's look at an example. Which is now filled. All right. Here's a web app. We've seen our little website, where people register, and we've seen where you can register and hit that register button. This. And for the technical folks, this is a gross oversimplification, but this will basically hit a domain service which does registration. It has its own database which stores registration information, and it publishes if all is good. If this guy is not registered already, if there are mandatory fields missing, and we will about that and other things, it publishes events. User as registered is one of our events. Here comes the thing. In this simplified view of the world, it doesn't have any of the searching and the notification stuff in it. There are two parties who are interested in that. The identity and access service, which needs to know about the new registration because it will later do logins. Authorization. Does username and password belong to a registered user? Right? For that, it needs to know who the registered users are. And for that, it has its very own database, which stores this, but nothing else. We're coming back to that, that's quite important. And your web app, which has a REST API, and you have whatever, your mobile thing or the website or whatever hitting that, also needs to know about that because it needs to display thanks for registering Barney and some mail and so on. It basically has a database which stores the views, all the presentation stuff. It will store verbatim. It calls no other databases to rebuild that. It simply knows from those events what should be on the screen and pops it up there. Reporting would work in the same way. Those are so-called read models, and they feed off events and store them, and they get stored in databases. Very high performing because you're not having to go anywhere else. So this is a small subset, just registration and identity and access of that overall gigantic system. And look at the pieces. We have what looks like 3 mini systems with their own databases, right? That's important because they're like small, not just font size, sorry about that. I didn't realize we were quite this far spread out, right? But they're small systems. This does only registration stuff. This does only authorization and authentication. This does only the website, and it pops up information on this. This is very important because Agile and waterfall and so on is kind of like, I wouldn't say bullshit, but the problem is, it would seem that how well software systems go is a function of size. The bigger your code base, the harder it is to understand, the harder it is to maintain. So this is ultimately an attempt to break down very large projects into these mini services which communicate through commands and events, right? This identity and access service does not know where a user registered. It just knows that one of those events came through the pipe. This could have come from a third-party system, could have come from somewhere else. Likewise, the registration subsystem does not know anything about who consumes the events. It just publishes the event. That's it. Doesn't know who consumes it. That's very important because it cuts down on meetings, right? If you just publish the event, and that's the end of it, the only bit of coordination you need with any other team is some agreement of what should be in the event for information, right? Beyond that, as long as that's there, you're good, right? So it's if you could build a system as those small, very independent little things, every component is simple, every component can be developed by itself, and every component is well defined in the sense that it has a known set of commands which act on it, register, login, add search, whatever in other components, and a known output, a series of events which happen as a result of those inputs, right? So you can now outsource that. You can now have it built by other people. You can now have that built by smaller teams who live, say, in the other office building somewhere, without constantly coordinating. Because are these guys going to blow away some central database because of dependencies? No, they live in their own world. There's only one way into that box, which is a command, and only one way out of it. It tells the world about itself via events. That is all. Imagine how you can cut down on overhead in management if you have this, right? And the way you get this is you look at those events, which we have from our event storming, and you start identifying what those services should be. And that's what we're going to look at next on how that's done. First of all, you have a conversation with our founder and with the business folks. You probably have that way before you even start event storming. And you find out what the domains are within which the business operates. It's not a website. It's not a technical thing at all. It's simply what's most important for the business, what areas are important for the business. If you look at a new sort of startup style scenario, like Fieldstorm, user adoption rules, right? Our founder wants to have millions of people using this thing. So one core domain where they need to be really, really good is user adoption, right? Search and notification, well, you can argue it's a technical thing. Yeah, you need to be good at searching and notifying stuff and so on. It's more of a technical thing. User retention is important. It may be the core domain, as in what the system, what the teams need to be really good at. It might shift to user retention as the business matures. These things are in flux. Eventually, he would like to make money. That's the revenue model with advertising, but he needs user adoption first, because without that, the advertising isn't very attractive. So for now, that is definitely the focus. And user retention, obviously you want these guys to stay around, right? Why are those domains important? It's also data and insights, right? Everybody's doing data and insights, tracking, coming to that, how events-based systems help with that. But why are those domains important? The domains are important because they are what we ultimately need to support when we assign the work to teams in such a way that they really can have a chance to get really, really good at user adoption, and they own everything to do with it, right? There has to be a team which does that, same for all the other stuff. It's also to identify things which are more generic, like identity and access. What do you build yourself? What can you do with other APIs or other services or something? So there's an element of buy-or-build decisions in there if you get the domains right. So these are our domains. This is a business discussion. Only technicians in the room, it won't work. This is really folks telling you what they actually want from the business side. So you know how to map technical artifacts to this. That's a mess. So, in order to do that, well, you need something, you need some context around that. But this is a mess. It describes sort of how hypothetical services overlap these things. It's called bounded context, right? There's a context of a registration, identity and access. There's this web app thing, which is a mess all over the map. And there's search and notification, and as a separate thing, there's a searcher and so forth. I'm not using user communities and advertising yet, because in the early minimum viable, there's no notion of this. So this would be roughly the areas which teams own. The core domain of registration, user adoption, identity and access, and so on. Web app is sort of a mess which covers it all. So how do we break this down? How did we arrive at those lines? Sorry about the screen size challenges. Let's see if I can fix that. Let's look at these bounded contexts overlaying the domains. What is a bounded context? A bounded context is a linguistic boundary. You basically determine which services, if you will, belong together based not on technical but on linguistic criteria. And for example, take a user. What's a user, right? Those of you who do technical things will know that a user can be all sorts of things, from a login to a users do everything in the system, but what a user actually is depends on where you look at what bounded context the guy is in. Look at registration. The language of registration is users can register with email address and password. The language of registration. Domain language specific to this. Identity and access. Users can authenticate with username and password and request a password reset. Okay, that makes sense. Search. Users can create a keyword search for multiple news groups. Look at how the language differs. Keyword search, news groups, that's the language of the domain of searching and finding things. Authenticate. The word authenticate doesn't belong into this particular context. Authenticate has no meaning in searching and searching news groups, right? It's a different thing. It's kind of cross-wired, and that's a key. Breaking down systems in such a way that the language within those contexts is consistent, makes them easier to maintain. Eventually these turn into technical boundaries, so you get services which map to those linguistic boundaries. That's because it makes it less likely that you need to coordinate among people and project manage excessively due to communications disconnects. If, for example, in identity and access, words like keyword search and multiple newsgroups occur, and this is suddenly in the same whack of code as everything else, people will need to understand both searching and authenticating people, which makes it more complicated. If you look at this from a car perspective, it would mean that, well, in the context of the safety systems of the car, a belt is a seat belt, right? In the context of the engine, it's a fan belt or a timing belt, right? So if you have these things mixed together, it means that suddenly the guy who services the engine needs to know everything about how the seatbelt system works and vice versa, right? It's about, ultimately, this is as old as the hills. It's early industrial revolution stuff. It's been validated by generations of engineers that it's best to break things down into discrete subsystems so that the guy who fixes your car stereo doesn't need to understand how to pop the trunk, right? It's old stuff. And if you do that, you get naturally easy to maintain systems. Problem with software has always been that, how do you do that? Traditionally, it's often broken down into technical artifacts, but that doesn't fly. It just gets coupled to one giant database in the sky, and it gets monolithic and so forth. So this event storming and domain-driven design attempts to do it along linguistic boundaries. And you look at consistent language. And from this, in the example I derived, those various sort of services, each of which have other components and so forth. But we got registration, identity and access, search, and notifications. And they overlap those domains, which we looked at earlier. So let's look at this from a let's look at this one by one, right? There's a registration context, and in that context, obviously that has a lot to do with user adoption. You guys who are really good in user adoption and social media and all the rest of it, not just technicians, should really be on the same team, which determines the nicest and slickest way to register and how to cross-promote this, all the rest of it. Ideally, it's one room with these people. And this covers, obviously, the user adoption. Registration covers user adoption in a big way. But there's also elements of identity and access, because we register with an email, and that is later context mapped. That's the password, and later for authentication in your identity and access. There is an element of user retention. You don't really want these guys to abandon registering halfway through. You want to sort of draw them in so they actually start trying the system. So if you draw this out and do a brainstorming, this is always together with the business guys, and you have your domains and how your contexts map to those, you get a better sense of what belongs together and what areas of expertise these guys need to touch. The search service, right? The searcher service has user retention in it. You want to make sure it finds things, right, and all the rest of it. And there's an element of notifications. You can live in community building by having most popular searches and whatever. And there's also data insights, what were people searching for, and so forth. You can again see how the bounded contexts, linguistic boundaries, and soon services and technical boundaries overlap the core competencies and domains in which the company does business. Notification here is pretty well delimited, but note that the search and notification stuff overlaps. If you look at that, search and notification, and just the searching parts closely related, right? Notifications and search. That's significant. We're almost there on what teams should own what. And then there's, of course, the web app, the whole front end of this thing, which covers everything, right? This is the overall impression and UI and user experience of the entire thing. So the web app kind of covers all of them, which is always complicated, right? Because how do you coordinate that? How do you make it? If you make it too modular, where everybody can actually own the various pieces independently, it means that it looks like a portal and it's boring. If you make it monolithic, possibly with business logic, then it becomes unmaintainable. So you can see that different bounded contexts, which we decided to make sort of identical with sort of the technical services underneath, overlap or don't overlap. You can see registration doesn't overlap much with searching, but the notifier service certainly does overlap with searching, right? So what you wouldn't want is a team which owns a searcher and another one that owns a notifier, and possibly have those guys geographically distributed, because if you do, it means because there are different languages spoken in this, different usages of words and terms, it means that Joe thinks a user does this and is that, whereas Anna thinks a user does this and does that, because their domain language differs. The more of such linguistic disconnects you have, the more bugs you're likely to get, and the more meetings you have to align these things. So it's worth putting considerable effort into getting this right. And so, what's the purpose of this exercise? The right conversations with the right people at the right time. Your user adoption team, let's say you have two teams, registration API and identity and access, because they're naturally aligned and similar in terms of language. And the search and notifications team, user retention, the entire area is not necessarily all technical. What makes it attractive so people use it more? And of course, search and notifications. They overlap. They overlap, and therefore they should possibly be owned by the same team. So, summary, we have events, and the language used in those events identifies where these get consumed and published. The various bounded contexts communicate through those domain events. It makes them independent and easy to maintain. We have the connection between the business and what the business is interested in doing, domains and codomains and so forth. And we have a mapping to context, so where the language between these things is consistent. With that in hand, we should be able to write fairly independent services where communications paths are clear. You minimize the need for teams to communicate with each other. At the same time, the overall picture is emerges as smaller, easier to make services. Oh my god, it's so horrible. None of this. Okay, so who's got lots of legacy code? Everybody has legacy codes. Okay, so how do you make this work with legacy code? First of all, before we go into legacy code, I expected a crowd where more people had heard about domain-driven design and event sourcing. Are we hitting about the right level with this? Questions? Let's open it up a bit first. I was going to get into techniques how to make this work with legacy code, Is this making sense? Is it theoretical airy-fairy?
Makes sense.
Thank you.
I have
Okay.
so if you have a big project and you have this context map, do you come to the brainstorming with the context map ready or without context map?
Without the context map.
So
Yep.
during the brainstorming context map is determined.
Yes, you do the event storming first, because the context map that's further down the line, right? It's in a nutshell that the context communicate with events. We saw that earlier, but first you need the events to ground the whole thing, if you will. It's basically a specification. It tells you what has to happen, and then you determine of where it happens, and then you determine of who makes it happen. Lots of iteration back and forth there, but that's roughly how it works. Yes?
Does this rules assume that any actions are always asynchronous? Like there's no way of saying, do a thing, you have results out of it.
It assumes that it's asynchronous. It assumes it's asynchronous. The reason for that is that it makes it more scalable. If you look at the previous example, it assumes that this is asynchronous. Commands are fire and forget, events happen, and things are eventually consistent. That seems complicated, but it has enormous advantages because, from a project management perspective, because as soon as you need something explicit back, you need to coordinate more, right? If it's fire and forget, and then events notify you of things, which can come from anywhere, it simply scales better from a technical perspective. It doesn't mean it's necessarily you can have the whole thing synchronous, but you cannot have something returning directly, right? Other questions? Yes?
So last year, Martin Fowler wrote an interesting blog post about microservices architectures versus monoliths.
Yes.
Said that basically the successful microservice architectures that he'd seen had started out as a monolith and then they decomposed.
Yeah.
Are you saying that this is a path to a successful microservice architecture that first building that monolith?
I would say that the problem with the monolith is a successful decomposition later, and I haven't seen examples where this worked flawlessly, right? And we've had some experience with that at Pay by Phone, but the problem is size, right? What kind of monolith? If it's a small thing which started as a spike, maybe. But I must say that with what I know now, I would straight away start with event storming and do it from the very beginning. There's simply not much reason not to. It comes together, it's less overhead, the technical stuff is not very difficult. What usually kills these things is communications overhead, delays because people misunderstand each other, waiting for somebody at the other end to pick up the phone. The reason why I tend to start over with this right away is because it addresses the project management and rollout and coordination things better.
So come to the cloud conference and argue it out with Golang. You're still talking about taking the monolith
It depends what monolith, right? This is again this is typical. Monolith depends again on what context. Are we talking 2001: A Space Odyssey? Are we talking a monolith in your organization or this organization or over there? What's a monolith, right? Yeah, I think it's a generalization which doesn't necessarily apply. Depends on context, which brings us. He always says, Adam, do chime in with this stuff, right?
Yeah, just sort of a bit of background. We just did a scoring session with one of my clients. It went quite well. I have a presentation next week actually of actually not next week, the week after. Maybe it's a week from now. Anyway, it's a little bit of a case study into actually applying it with some benefits to it that I didn't foresee. For example, we threw away all user story mapping because once we got proper events and the facts that happen in the system, we could quite easily rearrange them to make any story really quickly, take a picture, and go on to the next one. So, because we use the same names for everything in terms of what events happened and what data was in there in a language that meant something to everyone, we would see, okay, we're able to unite the whole organization in knowing what was being done, how it was being done, and without getting into technical jargon. At the same time, without getting into technical jargon, we're given when-then sentences and requirements for the technical team. So it killed multiple words in one stone. Yeah.
It does tend to do that.
That's kind of fun.
I'm coming to some of the cultural things which have to be in place for to pull it off. But this is, in a nutshell, the kind of thing why I would always start off with it. Other questions? Yes?
You could do make this like loggable, debuggable. So in one case it failed, but you try to reproduce what steps cause exactly that stack trace.
Yes. That's a very, the way I've done it before is you basically, let's say something happens in production, you have your event log, right? The events are logged in an event log with timestamps. And every aggregate, this is a slightly more technical thing, every aggregate, for example, every user in this world, every user in the context of somebody who has searches and newsfeed has a unique ID, and every event has one of those IDs with it, and every event has a timestamp. So you have a complete history of what happened to whom when, and you correlate that with logs, right? You have your logs from the code, and there too you make sure you always log those IDs, and so you can actually correlate that. Very, very powerful for troubleshooting. Nothing like it. I've never seen anything like it in systems which aren't event-based, because you have a complete history. You can replay, if it's a pure event source systems, they don't need to be, right? It can be just event collaboration based. But if it's an actual event source system, you can actually replay everything that happened to a particular user up to 5th of April. So you know exactly what state this guy was in, and your customer support guys can see it, and you can debug it and so on. So very, very well supported, because you can get snapshots of any moment in time when anything happened. And for individual services, here's the thing, you have a team, this is a trivial example of course, but you have teams working independently on those mini services, the services with high-grade aggregates and all the rest, all the technical stuff, right? But the point is, if you want to know how the system behaves, you only need this. You replay the events into it and build up its state, and you don't need any of the other databases. The only consistency you need is within your own service. In order to bring it to a moment in time where you want it, you replay the events to it. And that is a whole lot simpler and a whole lot easier to do in terms of managing side effects and in terms of having good test environments than a monolithic database, which is, many of those are basically not versionable, because versioning what, right? It's a dump with tables for just about everything. Whereas here, you version aggregates. Aggregate gets a little more technical. Wasn't meant to go into that direction. I have some stuff on my GitHub under a project called HIST, where there's some examples of where it's actually done. But in a nutshell, much easier to debug. Adam.
So just sort of a question for you and for everyone else. else who switched from object-oriented to functional programming in their recent career. One person. So there's quite a few people doing that. There's good reasons for doing functional versus object-oriented. What you'll find that that's events for your state, there's simply a left full of all of your previous events. So your current state is always just a projection of everything that's happened before. So it's really intuitive, sort of organized between two functional languages, and that would be a huge simplification for systems. But thinking this way allows you to adopt functional programming paradigms to what typically is sort of thrown into the whole world from domains, etc. So it's quite refreshing. You're really trying to keep your solutions light and small.
Yes.
Does that make sense?
So, going from an application where you just do a snapshot of data, and let's say you need to generate a usage,
Sorry, can you speak up slightly?
yeah, you can, when you have to do the data,
Yep.
you actually basically, in many cases, you know, do a query in the database to retrieve the data and
Yep.
for event sourcing events, then you need to replay the history to get to that point. How explicitly and how far back you go?
But depends, right? For performance reasons, you wouldn't actually replay it every time. If you look at Robert Reppel in GitHub, the examples in my list system, there are actual the examples replay all the events, even for the read models, every single time. But that's obviously not something you can do in production. So you snapshot them, right? In theory, what's missing here in this picture is there's some sort of giant event log somewhere, and you wouldn't, when you query whether somebody's already registered, you wouldn't do that by rehydrating every single aggregate. That doesn't make any sense. You would basically toss the information when events come in, build read models in whatever Elasticsearch or something. And but that's for the read model side of it. When it comes to actually hydrating events, the state of one individual event, you take snapshots. So you, if it's not practical to store these things all the way in the past, then you just snapshot the internal state, basically all the private variables in it, if you will, and store them to a database as a document, and then you just replay the events from then on.
The other thing I'd like to add is usually when you find yourself in that situation where you're crazy amount of events with the state of one aggregate, is that you probably got your design wrong in some way, or that entirely event sourcing is not the right solution for this at all.
Yeah.
So one of those two things, I found that it's actually quite a good litmus test for is your abstraction correct? So a lot of times something like a word order or something like a particular shopping visit for an online store, those are temporal things that tend to start and finish. Those are excellent candidates for doing that, because you rarely get into a situation where we're playing 1,000 things. They just come and go.
Well, we worked for a company for 10 years, and we changed the paycheck and whatnot. That's one of the things.
Yes, so that's a good example, but you can pick different objects to do that so you don't run into that problem. I would say that a person may move 10 times while they're at a company. So 10 events are not going to break the user's profile, right? Likewise, paycheck may be something for a pay period, maybe for something within a taxation time, so it could be per quarter, etc. Now those like individual IDs. You don't need to have it all sitting in one aggregate. It depends on your design. And it really pushes your design to make things in sizable chunks that are actually manipulable in terms of scalability or whatever. And when you get into tens of thousands or millions of events, you know you do the wrong thing, or this is just not a good solution for your problem.
Which brings us, that's very true, that brings us then into things which often fall flat with real-life older systems, about retention policies, or about how consistent does everything need to be at any moment in time and by what time and so on. All these things become far more explicit. I think we have one other one here.
just to be clear.
Yep.
When you're taking snapshots, it's per left hold operation, correct?
Say again?
So you're doing, so you have a bunch of events.
Yeah.
Right? And then when you want to snapshot, it's going to be dependent on what folder you're doing.
Yeah, it's a projection.
Yeah.
Yeah. The function
It
of
does,
whatever's before it, just equal.
Yep. Okay. A snapshot basically means you're dumping the thing into a database as a document in a similar way to what you've done in the old days before events. Think of a well-designed relational database system without events as something which only has the snapshots and no history. So, okay, so what I wanted to get into a little at the end here is what you do when you have a lot of legacy, right? So we have...
Maybe I have one more question about
Sure.
how everything fits together, because I noticed we're talking about domain-driven design,
Yep.
CQRS, event sourcing.
Yep.
As I understand, you have the DDD and you have this event sourcing, CQRS that actually go together quite well. But
Yep.
is there a place for each one of them to exist by itself?
Yes, I think that doing the event sourcing exercise, even if you are not doing the event storming exercise, even if you're not really in a position where you go to fully event sourced systems, for example, because you have a lot of legacy and it's just it just wouldn't work for you, is still extremely valuable because it brings together, like Adam said earlier, the business and the technical guys in aligning objectives. All right, we need the system. A user registration must have happened, right? Or a search must have succeeded, that kind of thing. It's a good shared language with the business, because in the end what your business guy wants is an outcome, and an event is something that happened as an outcome of something, and that's extremely valuable, I think, to avoid misunderstandings and get a better idea of the purpose of the system regardless, right? And
But isn't that part of, like, I understand how that being projected in the event sourcing,
yeah,
but the same concept are part of the pillars of domain-driven design, right? Is it the, so what I'm trying to say is that you can actually do just domain-driven design and you can get this fluency with the domain expert, and you don't have to go to event sourcing. So where is that place that I should say, oh yeah, event sourcing is fits for that case? What is that material that I need to look for?
event sourcing, I think, is,
If I can answer that.
yeah, go for it.
So there's two things. It doesn't have a place in domain-driven design. There are things in domain-driven design that fit, that make housing events really easy. Those would be aggregators where you can use events to restore that. But domain-driven design has no concept of event sourcing. Domain-driven design has value objects, attributes, language. It has all these things, bounding context, etc. And giving you the tools to organize your code, but it doesn't say how to do specific things. In terms of looking at event sourcing and storming, it doesn't give you the idea that you need anti-corruption layers or other domain-driven design principles. It gives you a focus on facts of the system, which are sort of very tiny Lego blocks that are immutable, which is great. From there, it's up to you if you want to apply domain-driven design, etc. That's what Robert's saying, is that those building blocks that you get from that conversation of getting events or facts that have happened, is that it gives you great material for any kind of system. Because you have to decide as to what are you going to persist. And it's going to draw some very, the smallest sort of transactional boundaries you can draw in your system. And that's a very good granular to have, because no matter what you build, that's going to be an immutable thing. Can't break those boundaries. Those are your atomic blocks. Right. So it helps you a lot in terms of bagging. So you can't say that just because they work well together, that some of these concepts are part of one another, because they're not.
So it was mentioned that there was a question about, in the first question about where is that event sourcing in the life cycle of when you build your software with the team. So been answered that it actually gets in before the context mapping, but is it just be after the ubiquitous language, or is it after the routing context, or is it after you define the core domain? Where is that coming in?
Well, that's the thing, is that it defines it for you. You kind of start with the building blocks, because like event storing is named for that purpose. It's so close to brainstorming. You want to do it as freely as possible. As the previous question was, do you do, some things like getting your bounded context correct and all that? No, don't bother. Let everyone come in with kind of a blank mind with what they're intending for their system to be. And you might find that the CEO has a very different opinion of what happens when someone registers, whether there's a credit card there or not, right? Whereas the service guy has a totally different idea, and maybe his experience with the initial parts of the system have been different, and he can actually have that argument with the CEO right there. And that's why that clarity, ubiquitous language, and shared vision for the technical stuff.
Yeah, that's exactly it, right? This whole stuff is about front-loading misunderstandings. Damn! You only noticed that the interpretation of the CEO of what this means is different. When we had our first release in front of a customer, that's not good. Event storming is always good because it front loads this kind of thing. The right conversations earlier. It's also good of course, it's an ideal input for event source systems. You can then identify your aggregates, your domain services, and all this other stuff, right? You can do all that. You can split it up into, assign it to teams to optimize it for delivery so that people who need to talk to each other, need to work together, and need to speak the same language as close together as possible. All the project management stuff we work on. You can also use it for totally different things. And that's the last example I wanted to show here, is how do you deal with, how can you use this to deal with legacy systems, right? That's not event sourcing, but it's a way of dealing with
traditional event sourcing.
Well, sort of. But in a nutshell, what's wrong with a legacy system? Nothing really. If it makes money and sits there and doesn't fall over too often, not too often being defined as acceptable for the business. The problem is if you have to change the thing all the time, because maintainability of code being a function of how big the thing is, you probably have 1DB, a database with a pile of dependencies and lots of things, updating things at random without rhyme or reason. And that's where it gets complicated. If you would not have to change your average monolithic, giant, messy, years of craft written into a legacy system, if you could just leave this thing alone, live with a steady source, live with the old bugs and the old features, well, people may like them from they certainly make money. If you could leave this thing alone, you'd be good, or at least much better, which is where a technique which is known from domain-driven design called an open host comes in. You basically wrap the thing in an API. The API looks clean, it's sort of like putting makeup on a pig, and behind the scenes is your really evil legacy system which does what it does and so on. And so that takes care of one end of it. Other systems can use an API which forms a sort of boundary around the legacy, but then you still, oh God, we should really add that new feature to the legacy. Well, no you don't. You can publish events from the legacy code and build the feature as a small service like the ones we've seen in the examples on the outside, right? So what you need for that is kind of hooks in the legacy system, which if somebody, say, registers a credit card in a legacy system, you would like to see a credit card registered event of some kind. So you can in turn make sure that the incentive system knows that there should be a special sign-up incentive or something. Do you whack the code for the incentive program into the legacy, or do you have a little service on the side? The service on the side should be faster because you don't have to do deployments, you don't have to do as much QA for side effects, all the rest of it. So one way to do it is to make the legacy system publish events, right? There's many variants, but there's two basic ways of doing that. You either make that hopefully final change to the legacy code, good luck with that. You instrument the legacy code to publish events. They go through the usual, an anti-corruption layer makes sure that they properly correspond to your domains or the rest of it. And you push them out as regular business domain events, which then can be used by new services. Basically, there's an API in front of the legacy, which makes it look nice, and the legacy talks about what's happening in the guts of it by publishing events. The other way is to scrape them from the DB. Who knows what, something which polls the DB for interesting things which happened. Heaven forbid you can use triggers or something. Whatever it takes to make this thing talk to outside systems to reduce the number of modifications you need to make. And event storming is very, very useful for that, to determine what actually should come out of the legacy system. You do it sort of as a reverse engineering exercise. You get the experts in the old system together and have them do an event storming of what actually happens in this thing. Then you instrument the thing and you get yourself hopefully much reduced need to ever touch it again.
I think it left out one bit is that you've extended by just having compensating actions in other systems outside.
Yeah, you can. That's right. I mean,
processors.
yes, compensating actions to reverse transactions and so forth is another possibility to use this. And so an open host plus event publishing. Why would you use it? There's good reasons and bad reasons. Good reason is it reduces number and scope of changes to the legacy code. And hey, legacy code, let's assume, is a moneymaker, right? Why would you not keep the thing running? Bad reason, in my opinion, is need-free. We're going to clean up this mess. It's unmaintainable. It makes us look like idiots. That's not a good. You can wrapping this thing in an API and then replacing it wholesale. I don't know. Refactoring the legacy, if it could be done, someone would have done it already. These days, I'm more on the side of just build the damn thing afresh. You're probably going to spend less time if you do it properly. But then, if you do it without domain modeling and without breaking it down into small subsystems and do it one at a time, you get yourself a big rewrite, which is also a bad idea because it takes too long. So I used to be a huge fan of this open host strategy and enabling the legacy code, but I must say I've done that a couple of times now, and although it has benefits, you always ask yourself in the end whether it wouldn't have been better to build something else which makes the company more money rather than focusing too much on the legacy code and the repairing thereof. Therefore, I'm a fan of using it for freezing legacy so you don't have to touch it, and using the events and APIs around it as a way to enable new products, not to redo, cleaner the stuff that already exists. It's a bit of a judgment call. So, questions about using events to kind of make it less necessary to change legacy. All right, well. So, this whole events lead to better understanding of business domains, leading to bounded contexts, leading to smaller, loosely coupled services, all the rest of it. Why isn't everybody doing it? It's too new an idea, and it requires cultural change. I think that's the main reason why this isn't very widespread. You have too many silos in most organizations. If this is a bunch of technicians doing this on their own, you're not going to get much of the benefit. Like Adam said earlier, this really needs the business guys all the way up and down the ladder around the table. It needs to be an initiative which gets it's in the end about communication and boundaries between systems and making sure that the business priorities and business usage of language and so on maps to the technical stuff to reduce the disconnects. And most organizations are just not set up to do that. This is probably familiar to some of you. You tend to have sort of the org chart reasons. You have a front-end team, a back-end team, perhaps a DBA team, and then a systems team. There's sort of wedding cake layers. Practically guarantees that things move slowly and badly because they constantly have different priorities and constantly have to coordinate all the rest of it. For this to actually work, your teams have to be truly cross-functional. It's not just a bunch of developers. It's a bunch of developers, but there's a bunch of business guys. For example, the user adoption guys should have a marketing and social media guys in it, all the rest of it. And it's a bunch of folks from the leadership available when necessary and so forth. And they must own the entire stack. No coordination with any systems group or anything of that nature. May I ask who is working in a, what you would say, a large company? Let's say, more than 500 people or so? Yeah. The bigger it gets, the more you tend to have those organizations where this is very hard to pull off because you simply just don't own enough of your stack to make it work. And on that really positive note, thank you. Available for questions, all the rest of it.